Hello, today's video will be an introduction into forces. So, table of contents. Firstly, we will give the definition of a force, then go through Newton's first law along with a practice question, and then Newton's second law along with a practice question. So, what is a force? A force is a push or a pull upon an object. A force can only exist when two objects interact with one another. Examples include a person pushing on a box, friction between two surfaces sliding across each other, or thrust from a rocket engine, the third of which involves Newton's third law, which will be covered in a future video. Forces are measured in newtons, named after Sir Isaac Newton, the scientist who came up with the laws. So, here's a list of forces that you should know. Gravitational force, also known as weight, not to be confused with mass. Applied forces, which is a push or pull upon an object. Friction, which is resistance between two surfaces that make contact with each other. Air resistance, which is friction between air molecules and a moving object. And tension, which is the force in a rope when two opposing forces act upon it. Now, Newton's first law of motion. Newton's first law of motion states that an object at rest remains at rest, or if in motion, remains in motion at a constant velocity unless acted upon by a net external force. Now, what does this mean? So, if an object remains still, it will stay still unless an external force is acted upon it. This is because the resultant forces is zero, the resultant force which is the combination of all forces acting upon it. Similarly, if an object is moving at constant velocity, unless another external force acts upon it, it will remain at constant velocity as the resultant force is zero. A still object does have a speed of zero, as such, the same logic can be applied. For example, the book on the table will remain on the table unless I push or pull it off. So, the resultant force initially is zero, but when I push it, the resultant force is no longer zero, and thus an external net force is applied on it. For the example on the right, the car will remain in a constant velocity unless another external force is acted upon it. For example, when the driver steps on the throttle and the car accelerates. Now, for a practice question. If there are no external forces acting on the car and it is moving at a constant velocity, what is the value of the frictional force, F? Pause the video and take a moment to figure it out. The answer is 3 kilonewtons. We know that the car is moving at a constant velocity, and as such, the resultant forces must be equal to zero. Because of this, we know that the frictional force must balance out with the driving force. As such, the frictional force will be equal to the driving force. Therefore, we can deduce that the frictional force is 3 kilonewtons. Newton's second law of motion. Newton's second law of motion states that the force of an object is equal to its mass times its rate of change in velocity. In mathematical terms, this means that the force is equal to its mass times its acceleration, where the acceleration is the rate of change of velocity or speed of an object. Force is measured in newtons, as previously mentioned, mass is measured in kilograms, and acceleration is measured in meters per second squared. Do try to remember this formula, as you will be using it a lot down the line. Now, for another practice question. There are 3 trolleys, A, B, and C. They are all acted upon by an equal force. Figure out which one has the smallest acceleration along with a reason. Pause the video and think of an answer. The answer will be C. We know that the force acting upon the 3 trolleys is equal, and the mass increases from A to C. As such, in order for the force to remain constant among all 3 trolleys, the acceleration across must decrease from A to C. As such, the acceleration of trolley C will be the lowest out of the 3. Thank you for watching, and I hope you found this video helpful. Next time, we will be covering gravity and weight.